ओम नमः शिवाय। नमो नमः। अद्य शुक्रवासरः। अद्य अद्य महाशिवरात्रि अस्ति। अस्मिन् शुभावसरे अद्य अस्यां शैक्षिक अनुसंधान विधि विषये द्विसाप्ताहिक कार्यशालायाः नवम दिनांक अस्ति। अस्या कार्यशालायाः नवम दिनांकस्य प्रथमसत्रे सर्वेषां स्वागतं सुस्वागतम्। बहु कार्याणि सत्त्वे अपि अस्माकं समीपे आगतवत्याः प्रोफेसर एन कलरई महोदयाः कलयरसी महोदयाः ताभ्यः अपि विशेषरूपेण स्वागतं कुर्वन्नस्मि। अधुना प्रोफेसर एन कलरसी महोदयाः परिचयं किञ्चित् दातुमिच्छामि अहं। महोदयायाः शैक्षिक अनुसंधान विषये बहु गभीरतया ज्ञानम् अस्ति। महोदयायाः कार्यदक्षता अपि बहूनि सन्ति। तदेकवारं वदन्नस्मि अहं। महोदया तु 34 इयर्स् अनुसंधान कार्ये नियुक्ताः सन्ति। महोदयाः एजुकेशनल क्वालिफिकेशन MSc मैथमेटिक्स, M.Ed, M.Phil एजुकेशन एंड PhD एजुकेशन शास्त्रे। Mahodaya qualified as a master trainer under the Intel at the rate of Take to the Future program by completing the master trainers course conducted, and also trained 10 teacher in pre-service curriculum of Intel, and undergone Microsoft Planner in learning training program conducted by Microsoft IT Academy in collaboration with government of Tamil Nadu, and successfully completed XPDI-TTE and Intel project organized by Intel in collaboration with NCT. Qualified as master trainer under the Intel Tech program essentials course organized by Intel in teacher education program, and training on specific learning difficulties, dyslexia at Alpha to Omega learning course and learning center Kilpauk, Chennai. रिसर्च एक्सपीरियंस मध्ये तु महोदया बहूनि शोधकार्याणि कारितवत्यः एवं M.Phil अपि कारितवत्यः। तस्याः अधीने ताभ्यः अधीने M.Ed अपि अभवत् इति बहूनि। महोदयाः पुनः एकवारं सुस्वागतं करोमि। महोदया अस्माकं समीपे अनुसंधान कार्य विषये अनुसंधान दक्षता यदस्ति महोदयाः तस्मिन् विषये अस्मान् अनुसंधान विषये बोधयन्ति। महोदयाः अनुरोधे भवत्याः स्वीय प्रस्तुतिं प्रकटयन्तु इति सम्प्रार्थये।
August forum. I'd like to extend my prayers to the Almighty for giving me the opportunity to be in this divine place of the world, and that too in the auspicious day of Mahasivaratri. I would like to extend my heartfelt gratitude to the director of this program, Professor Mr. Dr. Venkat Rao, and the coordinator of this 12 days workshop, Professor Chandrasekharan sir, of course, but not the least, we are Vice Chancellors of this university, and all the members who are involved in this, in conducting this 12 days workshop, this 2 weeks workshop in such a meticulous manner. Getting into my deliberations on this, the first session is going to be on normal probability distribution. You know pretty well, anything we deal with in this society, we talk about average. Maybe the average salary, average income of the family, average marks, okay, to get through the exam, to qualify some degree and so on. So that is normal. Normal is which is popular, which is acceptable to everyone. For example, if I plot the height of all the participants available in this room, or if I try to plot the weight of all the participants available in this room, it will follow within a curve. When I try to plot everything, when I try to draw a graph, it will be in the form of a curve. That too a bell-shaped curve. So that will be a bell-shaped curve. So a normal probability curve is a bell-shaped curve, which has got where most of the data will be centered around the center, and few data will be in the towards the left tail, and also few data will be centered. You will find few data on the right end of the tail. Most of the data will be in the center of the tail. That is normal probability curve. Before getting into certain details of all the statistics, I want to make certain things very clear for you. What is data? What is the plural form of data? Is there any plural form of data? Yeah. Data itself is a plural. Then what is the singular form of data? Data. Okay. So I am talking about data. So statistics we deal with data. Set of numbers, numericals. So the normal probability curve is a bell-shaped curve within which you will find most of the things falling within the, maybe in the normal probability curve we divide that into sigma portions. 1 sigma, 2 sigma, 3 sigma. Okay, left hand side you will find minus 1 sigma, minus 2 sigma, 3 sigma. Right hand side you will find plus 1 sigma, plus 2 sigma, plus 3 sigma. So normal probability curve is a perfect, 100% perfect curve where the perfect balance is maintained in the center ordinate. The perfect balance is maintained in the central ordinate. The central ordinate where you will find mean, median and mode coincide. So there is a bell-shaped curve where you find the central ordinate in which mean, median and previous. Next. So most of the scores you will find in the middle portion of the curve, and this number decreases as I told you in the both ends, towards the left hand as well as towards the right hand. For example, in the physics, like your height, weight, all these things performs under normal probability curve. Any community, any society you take it, if you try to plot, definitely will fall within the normal probability curve, especially when you take a larger sample. When a sample size is very large, definitely things will fall within the normal probability curve. So, physics, your height, weight, temperature. Biology, you can have age, blood sugar, you try all these things. Among your groups, also you can try. Okay, it will fall definitely within the normal probability curve. And the normal probability curve, the mean, median and mode coincide. It will fall under central ordinate. Left side of the mean, median, mode, you will find 50%. Right side will under 50%. So this is this left half will be the mirror image of the right half. Now probably you will try to fold your curve along the middle line. You will find the left to be the just mirror image of the right, or right will be the just mirror image of the left. So you know pretty well. Now probability curve, the median is the middle one. What is median?
Average.
No, median is not average.
Middle of the point.
It is a point that divides the distribution into two equal halves.
Yes.
Okay, it can be average, it need not be average. Only in the NPC it will be average, not everywhere. Only normal probability curve, median will be the average, median will be the mode, because all the three coincide, nearly equal. Okay, but other skewed distribution, when the curve distorts from the normality, when it is asymmetrical. I said the normal probability curve is symmetrical about the central line, about the mean and median and mode. When it is asymmetrical, when it falls on one side, when it leads over the other side line, then median will fall at a different point. Mode will fall at another different point. they need not be the same. Okay, so in the normal property curve, the mean, median and mode coincide. Yes, next one. Since the mean and mode coincide, it has got only one mode. It is a unimodal curve. It is a, what is a mode? The data which gets repeated more number of times. Okay, which gets repeated more number of times. The data which gets repeated more number of times is mode. That is a mode. Okay, normal property. Sometimes you will have multi-mode also. There are few numbers which gets repeated equal number of times, equal highest number of times. There are certain distributions in which certain data will get repeated equally higher number of times. Then in such cases, it will be multimodal distribution. I think I am getting you. Okay? Okay. There are certain distributions in which there will be only one mode. So, bell-shaped curve, now probability curve, it's a unimodal curve. So, it is symmetric about the middle ordinate, that is the median. It is symmetric, it has got only one mode. So, it is not a multimodal distribution. It is a single mode distribution. Now, probability curve is a single mode distribution. You can stop me at any point. If I am fast, you can raise your questions also. Okay, I might be fast. Next. Next. This is the normal property. This is area. So you find a bell-shaped curve. Yes or no? Yes. Can I have something? So the middle. This is the you find the mean here. You find the mean. You will find the median also here. You will find the mode also here. Okay. So this is the highest ordinate. Yes or no? So that is what is unimodal. So you are not getting this kind of curve. Okay. Suppose.
Shape.
Suppose I have now like this.
He wants to turn the button.
Okay.
That he gets slowly. Sanai. Agre agachantu. Agre agachantu. Yes. That's all.
तत्र सर्व मार्गपुर यदस्ति तत्र निष्णाते एकं रेट् तत्र भवति अथवा ये चलति तद् भवति तत्र
Suppose I have distribution like this. See?
अग्रे आगच्छन्तु न दृश्यते
They are
चेत्
equal.
बालिकाः
This is bimodal.
अग्रे आगच्छन्तु अत्र उपविश्य पश्यन्तु
You get my point. So this is bimodal distribution. Two modes are there. They are equal heights. But whereas in normal property curve, it is a unimodal distribution. You will find only one mode in the normal property curve. So coming to the area property of the normal curve. See, I said in the normal property curve, in the middle ordinate, this is the mean, this is the median, this is the mode. This is indicated by z equal to 0. I will come to z a little later. Okay, just make a note. It is z equal to 0. So from here, z minus 1 sigma plus 1 sigma, minus 2 sigma plus 2 sigma, minus 3 sigma plus 3 sigma. So 99.73% of the cases will be covered within minus 3 sigma to plus 3 sigma. When you take 100% of cases for your distribution, 99.73% of the cases will fall between minus 3 sigma to plus 3 sigma. So for all practical purposes, for all calculations, we will take only minus 3 sigma to plus 3 sigma. Because the other ends are very minimal. It is only 0.14%, the right end. The minus 0.14% in the left end. Is it not? So it is very minimal. For all practical calculations, for practical purpose in statistical analysis, we consider only between minus 3 sigma to plus 3 sigma. So between minus 1 sigma and 1 sigma, 68.26% will be covered. In your distribution, 68.26% will be covered between minus 1 sigma to plus 1 sigma. Between minus 2 sigma and plus 2 sigma, 95.44% will be covered. And from minus 3 sigma to plus 3 sigma, it is 99.7%. That's what you find in some of the books, this formula is 68 to 95 to 97.3 rule. I think you must have come across this. 68 to 95 to 97.3 rule. What is 68? It is the area covered between minus 1 to sigma to plus 1 sigma in a normal curve. And 95 is minus 2 sigma to plus 2 sigma in the normal curve. Whereas 97.3 is that? Sorry, 99.3. Say 99, sorry, 99.3 is the minus 3 sigma to plus 3 sigma. This is the rule you find most of the books. The first and third quartiles are equidistant from the median. What is the median? Median is the point which divides the distribution into two equal halves. So what is first? When I consider a distribution, when I represent a distribution through a straight line, suppose if I try to represent my distribution by a straight line, it is the point, median. Okay? So below which you will find how many percent? Below which median you will find? 50% of the distribution. It is the point that divides the distribution into two equal halves. So below median you will find 50%. Above median, another 50%. Okay? Suppose how many points are needed to divide the distribution into four equal parts? How many points are needed to divide the distribution into four equal parts?
25 each.
How many points are needed? 3 points. Okay, 3 points are needed to divide the distribution into four equal parts. Okay, so this is Q1 and this is median, nothing but Q2. Okay, and this one is Q3. So this is first quartile. First quartile. Below which you will find how many percentage then? 25%. Exactly. Median, as I told you, 50%. This is first quartile. Okay. And this is third quartile. Below which you will find 75%. Okay. So this Q1 and Q3 are equidistant from the median in the normal curve. The first and third quartiles are equidistant from the median in the normal curve. So when you plot the Q1 and Q3, you will find the mirror image of Q1 at the point Q3. Okay, because it is symmetric. Normal property curve is symmetric about the central ordinate. It is a mirror image. And the curve is not skewed because it is perfectly, it is balanced curve. It cannot be skewed. Only the balance is shifted, it will become the skewed curve. Because mean, median, mode pass at the same point. Even the skewness formula, when we just go through this, you will understand that, how it is not skewed. Next, it is asymptotic in character. What is meant by asymptotic? The normal property curve, you please go to the previous one. The normal property curve, both the ends of the curve keeps running parallel to the x-axis, keeps on running but never touches the x-axis. It will, as it goes, it will go very, very close to the x-axis, but it will never touch the x-axis. This character is known as asymptotic. The normal property curve is asymptotic in character. So the lines of normal curve run parallel to the x-axis, it will never touch the x-axis. And next, the total area of the normal curve is considered as equal to 1. Keeping that in mind, only we are going to work out all the problems. You consider the total area covered under normal property curve as 1. In that, 99.73% is covered with a minus 3 sigma to plus 3 sigma. Keep that in mind. Okay, next. The mean deviation of normal curve is 4/5 of the standard deviation. You know standard deviation. Mean standard deviation, some parameters. Okay, the mean deviation, average deviation is known as is 4/5 of a standard deviation in a normal curve alone. So given standard deviation, given standard deviation, you can find mean deviation. Once you know the standard deviation, you can compute mean deviation of a normal curve. Mean deviation is nothing but the average deviation. Okay, next. So once you know in the problem they may give you mean and standard deviation. Then you can compute mean deviation of the curve, the normal curve, using this formula. Only for the normal curve. For all of the problems you will apply the formula. Remember the average deviation formula you will apply to compute average deviation. But for normal curve you need not apply the formula. If you have standard deviation, you can very well compute the mean deviation by taking 4/5 of the standard deviation. Okay, suppose standard in the NPC, the standard deviation is given as 14.7. How will you find mean deviation? That's all. For all of the things, you have to apply the formula. Okay?
Ma'am, excuse me. A very simple question. In all the collection of sample data, why the NPC at the middle exactly that's as symmetrical, and why the both sides are not touching the x and y axis?
The nature of the distribution such, okay,
In all the data.
In all the data. In all the data. You take the population of India. You take the your height, as I told you, height of this person in this room, weight of this person in this room. You try to plot. Because this one, everything will fall under some certain structure. Isn't it? In the nature, everything will fall under certain structure and rule. The data are always such a way that it will fall in the normal form.
And you told the other type of NPC, which is the bimodal.
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 Ah.
Why there comes the two model?
Because there are, see, for example,
As you told, all the data come as symmetrical. Then why it comes two symmetrical?
So when you take all the data in the sense, when you take the data randomly, arbitrary random data, but when you have certain populations, for example, even in this group, okay, when you will find, say, 3, 5, 8, 17, 8, 4, 6, what is the mode in this? Which is mode?
8.
Why 8 is the mode?
2 times it's repeated.
2 times is getting repeated. Okay. Suppose I have, what is mode here?
2 more 17 and 17.
This is a my model distribution. This is my model distribution. This distribution doesn't fall under normal NPC. See? 8 is getting repeated 2 times. 17 is also getting 2 times. So it is a bimodal distribution. This data will not fall under normal probability curve.
Such like by other types are the tri.
Yeah, bimodal, trimodal, multimodal.
Okay.
More than 3.
It's in group data.
Group data it appears. Within the frequency curve you will find, when you draw a frequency table, at 2 plots you will find the highest frequency. Then you will get bimodal. When it is a bimodal distribution, you will apply different formula.
Okay. So even in the simple numbers we get 2 times repeated this bimodal. If in a big data, why cannot it differ like this?
Then if it differs like this, it will become a skewed distribution. It is not a normal distribution.
So it won't come under NPC.
No, it will not come.
So it is not that all the data can come under NPC.
No, not necessarily. But
So
generally
from
we
first
expect,
day we are saying that all data will come under NPC.
that's what we expect, everything to come under NPC.
Okay.
Okay, we want everybody to get through the exam. But sometimes there are certain students who fails also. We find IQ of the people. Okay, what is the normal IQ of the people? 90 to 110. So this will fall under one NPC. Whereas beyond 110, high IQs, like Einstein. Below 90,
No idea.
low IQ. This is also possible. Similarly, there are certain distributions which can be, because that's why we are talking about skewed. If everything is going to be there, we are going to talk about skewed. A perfect balance cannot be maintained for certain distribution, for certain reasons also. Suppose you are collecting the data. When you are collecting the data, you might give in some schools you think, when some colleges you may think, they are very remote colleges. Students are not that much maybe knowledgeable. You try to help them. So you have to answer like this.
In all
You have
the
to
data,
put
there are different
report
dimensions
like
of
this.
it.
So these all things will create an error. These will create an error in your analysis. That's what we talk about standard error also.
Excuse me, madam. We are collecting the sample.
Yes.
Without the testing of the NPC, can we go for analysis?
No. If you are going
This is
to
for you.
see,
No, this is for you. If you go and verify our thesis wherever you go, without the testing of the sample, we should not go for analysis. That's why NPC is very, very mandatory.
and when we come to parametric test, I will say that.
Nah.
So if you are going to apply for parametric test, first condition is to check for normality. If you don't know anything about the distribution I'm not quite confident, then go for non-parametric.
Non-parametric test.
But non-parametric tests are, I'm sorry to say, they're little substandard in analysis. I'm sorry to use the word.
Yeah.
Because there is no other go. There are certain situations where I can depend only on the
Because
frequency.
we cannot change the sample.
We cannot change the sample. There are certain situations we can depend only on the frequency, not on the real data. For example, if you are working...
After all this, all the children can be given some data and give a model of NPC. They can, an example, hands-on like.
Later when we use the hands-on experience, they will.
So you may have a data, no? So there are certain situations where the frequency, you cannot decide about the frequency. For example, you know about, you must have learned about correlation.
Yes.
Correlation. There are two ways of, to start with, there are two ways of computing correlation. One is Spearman's rank difference method, another one is Carl Pearson's product moment method. In the Carl Pearson's product moment correlation, you take the real data as such. You use the real values as such. Whereas in the Spearman rank correlation, you will use, see in the Pearson's product moment correlation, you will use the real data. The data as such is taken considered for calculating purposes. When you are working with Spearman's rank correlation, first ranks are assigned to the data. After that, only ranks is taken into consideration. Real data is not touched. Do you get my point? Maybe the first data might have been, first rank would have been 90. Whereas the second rank would have been 62. See, that's a vast difference is there.
Rank order going with it.
Because ranked order. So it is non-parametric. That's why non-parametric sets are little substandard when compared to parametric sets. When you talk about parametric, when you are going to do a high-level research, very sophisticated research, definitely you try for parametric test. When you are going for parametric test, first conditions check for normality. If the distribution was not normal, the whole thesis is.
I request you, ma'am, the distribution is not normal. That's why please explain the skewness about the.
I'll come to it.
Then only our students will understand.
I'll come to it later. My class second section is on that.
Yes, ma'am.
So, next is between, can I proceed?
Yes, ma'am.
So, it is a mean deviation, fourth of the standard deviation. So, between u minus mu, that is, mu is another word used for population. I'll come to that also. So, between mean plus 1 sigma and the mean minus 1 sigma, you will find, everything is given over there. Please go to the previous one. See, between mu minus 1 sigma to mu plus 1 sigma, the curve is downward. The curve is downward. From minus 1 sigma to 3 sigma, the curve turns upward. So what is physics students must be able to say? What is this? Convex. Is it not? From this point it goes to concave. So these 2 points are known as inflection points. Points of inflection, where the points at which the curve changes its position from convex to concave. Do you get my point? Yes?
Yes.
So minus 1 sigma and plus 1 sigma are the points of inflection points, where the curve changes its direction from downward to upward. That's what I given this. That's what I given you, inflection points. Okay? Yes. Going to the next. A normal curve with a mean value is 0 and sigma equal to 1 is called a standardized unit normal curve. So we use always standardized unit normal curve for doing all our calculations. Your table values will only refer to that. You will have standardized is a table there. Okay, no NPC table. Sorry, the NPC table is available in your standard books like Garrett and other books. You will refer to that only with reference to. That's why area on the normal curve is, the total area on the normal curve is 1. The total area under the covered of the normal curve is 1. I have given the property earlier, right? Area property studied in the normal curve between 0 and 1 sigma, it is 0.3413. That's why I given 34.13%. Go to the figure, please go to the figure. Previous? 34.13. So when you convert to 1, 0.3413. So percentage 34.13 minus 1 sigma to plus 1 sigma, 68.26%. But when you talk about area, because since I am considering the whole area as 1, the area is between 0 to 1 sigma is 0.3413. This I am talking about percentage. There I am talking about the value in terms of taking total area to be 1. The same thing is converted there. I think you are getting my point. You are getting it. Okay, go to the next one. Next one. Between 0 and 1 sigma, it is 0.3413. Between 0 and 1.9 sigma, it is 0.4750. And between 1.96 sigma to plus 1.9 sigma, it is 0.95. And 2.58 to plus 2.58, it is 0.99. This 1.96, 2.58 are the Gita's right in our statistics. Why? When you are testing the hypothesis with reference to T, you know T test? Small t, student's T test. When you are working on student T test, you will be considering the table value of, always when you are doing the statistic, doing calculation, you get one value. Different you get value. This
So
value.
last one can we say like this? Minus 3 sigma 2 plus 3 sigma.
The same thing is converted
Can
here.
we say that's what they are?
Yeah, I am coming to that. Okay, so when you are consulting, when you are doing the calculation, you will arrive at one value. Always this value has to be referred to your table value. This is like when you are getting a diagnostic report from the lab. They will give observed value, they will give another column is
Standard value.
referred value or standard value. You will see your value is greater or smaller. It is straight, it is small, we are safe. Yes or no? You must have seen the diagnostic report. You are referred to the standard value. Similar to that, in T test, you will refer to minus 1.96. 1.96 is the value, accepted standard value for 0.057. 2.58 is the accepted standard value for 0.0111. Okay, so this is nothing but 1 sigma to 2 sigma. This is minus 1 sigma to plus 1 sigma, minus 2 sigma to, sorry, this is 1 sigma to 1 sigma, this is 2 sigma to 2 sigma. Okay, this is how you are considering. And when you are doing problem, you will be able to understand. Okay, just you make a note of it, when I am doing, you will know. Go into the next one. Yes? If the mean and the standard deviation distribution is known, then it is used to find that these are the applications. So far we have considered the properties of the normal curve. It is a unimodal curve, it is symmetric with the central ordinate, mean, median, mode falls at the same point. The total area is considered as 1. Though it is considered as 1, between minus 3 sigma to plus 3 sigma, 99.73% is covered. It is asymptotic in character. The curve runs parallel to the x-axis, it will never touch the x-axis. So the area of the curve is taken as 1. So these are the properties. How are you going to apply the normal property? What are the applications of normal property? So these are general applications. I am going to work out problem based on this also. First, if the mean and standard deviation distribution is known, then it is used to find the percentage of cases falling within the given limits. They are given mean and ST. How many % will fall between two limits? That you can compute. In the problem, they are given you mean and standard deviation. Between 95 and 140, how many % of cases will fall? Suppose NEET exam is conducted, NEET UG is conducted, or UNICET is conducted. So NEET UG 800 marks, if the exam maximum marks is 800. So between 640 and 720, how many % of cases will fall? How to find out? This is the first application. Do you get my point? Okay, for example, you are writing your MPhil program or PhD. The PhD is coursework. The paper is for 100, maybe the paper is for 200. Between 140 and 195, how many % of students will fall? That is the knowing mean and ST, I can compute that. Do you get my point? Given the limits, how many % will fall? That is done through the NPC. Second is, given the percentage, between which limits these two, the percentage will fall. Given 80%, between which, given mean and ST, 80% of the students will fall between which limits? What are the ends between which 80% will fall? That is the second application. And third one is it is used to convert the raw scores to integral score. There are certain situations. For example, you are conducting a test for 15 marks in your class. You are conducting another test for 35 marks. Okay, how to compare these two marks? What will you do? You are conducting one test for 15 marks. You are conducting another test for 35 marks. What will you do? How will you compare the scores? A person getting 12 out of 15. Another person getting 22 out of 35. Are they same? How do you compare? Generally, you forget about NPC and all. Or you are conducting test for 20 marks. You are conducting another test for 100 marks. How will you compare those two scores?
Convert the 20 into
20 into
100.
100, that's all. You are bringing it to a common platform. Okay, that vehicle cannot buy this. You convert the raw scores into Z score. Z scores are standard scores. Because one tool is for 120 marks. Maybe there are another tool for 85 marks. I want to compare these two tools. So I want to find a correlation between these two. You convert that into Z score. Z scores will bring about commonality. So converting raw scores into standard score, that is Z scores. Z scores can be further converted into T score, capital T. This is different from student. Okay, so these are the standard score which is used in the psychological testing and all. So NPC can be used to convert the scores into standard scores or Z scores. Okay, next. It is used to divide a group into given number of subgroups based on a trait which follows normal distribution. So if your trait follows a normal distribution, you can divide the groups. For example, I want to divide a group of students into 3 groups. One is average group, another one is low group, another one is high group. I want to compare how this particular treatment is effective for low group, for the non-normal group and average group. How to divide them into 3 groups? I have set of students. I want to divide them into 3 groups. One is below average group, low group. Another one is average group. Another one is high group. How particular treatment is effective? Who is benefited better? Maybe you are teaching through online learning. You are trying to teach because new normal. Online teaching has become new normal nowadays. So you are interested in teaching through online. Which group is benefited more? Is it the low group or the normal group or the high group? This is my question. We think this is what normal. We think like that. I don't know how it's going to work out. Okay, how to divide the students into 3 groups? Scientifically speaking, there are 2 ways of dividing. Statistically and scientifically. Don't take their class marks and all. Consider class marks, take below 25. No. You either divide the students into 3 groups based on Q1 and Q3. First quartile, third quartile. Those who are getting below Q1, low group. Those who are getting above Q3, high group. Between Q1 and Q3, moderate group. This is one way of dividing. Another way of dividing is mean minus 1 SD and mean plus 1 SD. That comes the role of NPC. Mean minus 1 SD. Those are getting mean minus 1 standard deviation. Mean minus 1 standard deviation. That's why given the normal curve, mean minus 1 sigma. Sigma is standard deviation notation. Those who are getting less than mean minus 1 sigma, you consider that as group. Okay, so another one is mean plus 1 sigma. Those who are getting above mean plus 1 sigma, you consider them as high group. Those lying between mean minus 1 sigma to mean plus 1 sigma, you consider to be moderate. This is how NPC finds places. When I want to divide the distribution into number of subgroups, generally we compare like this only. Which is effective, which group is benefited more? Is it average group or low group or high group? How to divide that? This is scientific way of dividing. Suppose you want to divide them into 4 groups. Q1, Q2, Q3, Q4. Below Q1 low group, second group, moderate is Q2 to middle one, median. Second group, median to Q3, third group, above Q3, 4 groups. Suppose I want to divide them into 5 groups. What would I do? My objective is to divide them into 5 groups. You divide. Whatever we are talking is all scientific thing. This is not arbitrary statements. Whatever doing is the statistical scientifically proved. It is percentiles. When you divide them into 5 groups, percentiles P20, P40, P60, P80, above P80. So percentage comes into role, play its role here. I want to divide into 10 groups. P10, P20, P30, P40, P50, P60, P70, P80, P90, above P90.
Like we use CGPA marks we use.
Not percentile, not CGPA. You have a specific formula to find percentiles. It is there. And in fact, your median is that P50. 50th percentile is your median. Your Q3 is
75?
75. 75 exactly. 75 percentage is your Q3. Your Q1 is 26%. Okay? So you have fun. This is how NPC used to divide the groups into number of subgroups scientifically. Can I proceed? Any doubt up to this? No. Yes. Next is to compare two frequency distributions. That's all we'll come to that later. We will come to result score and we will compare the two frequency distributions. A person is getting this mean and ST in one kind of exam, another kind of mean and ST in another kind of exam where he performs better. Compare two distributions. And next is to test the hypothesis and levels of significance. Always you die. That's what Sarah, this is the last point. Normality to test the levels of significance, testing the hypothesis. Where do you test the hypothesis? When you are doing research. When you are doing research, first test for normality. That's all. Satisfying to my told you this. To test the hypothesis and level of significance. So coming to this, next one. I am getting into the application now. I have given such a list of applications. This is the first application. The normal probability curve table is generally limited to areas and the limit normal curve where n is 1 and sigma equal to 1. In case when the case values of n and sigma are different from these, the measurements of scores should be converted into sigma scores. This is referred as Z scores. How to convert into Z score? X minus mean by standard deviation. So x minus m by sigma, where x is the last score, your arbitrary score, and z is the standard score. Mean is m is the mean of the scores, and sigma is the standard deviation of the scores. Even this one I am converting into standard score using this formula. X minus m by sigma. Yes, next one. Suppose in a frequency distribution, n is 1000 and the mean is 110, ST is 20. Find the number of persons scoring between 100 and 130. The first application. Between the limits, how many percentage will fall? That is the first application, no? Yes. So limits are given. 100 and 130 are the limits. We want to find how many percentage of cases in this 1000 will fall between 100 and 130. First, compute Z for 100. I am computing Z for 100. Z is x minus m by sigma. Your x is 100 now. 100 minus, your mean is 110. Sigma is 20. 100 minus 110 by 20. You are getting out today, work it out. The same thing I have given here. Okay? 100 because I am converting this 100 into Z score. And this 130 into Z score. So 100 minus mean is 110 by standard deviation is 20. So it is minus 0.5. And the 130 is converted into plus 1. So this is central ordinate. I am sorry for this figure. I couldn't draw the figure with the help of the PPT, so I drew it in the paper. I just took a photograph. I placed it here. Okay, back to this. I think it is visible for you, this figure.
Yes.
Okay, so minus 0.5 to plus 1. Always minus will fall on the left hand side, plus will fall on the right hand side of the middle ordinate, isn't it? In a normal curve, left side is minus, right side is plus. This is minus 0.5. Is that equal minus 0.5 here? Is that equal to 1 here? Is it not? You are trying to find out the area between these two. Okay, I want to know what is this limit. What is this? Well, how many percentage? I want to find percentage of cases falling within these two limits. This is given as 100, another one is given as 130. So I have converted Z score. Z score corresponding to 100 is minus 0.5. Z score corresponding to 130 is 1. Okay, I want to find percentage of cases falling within this limit. So for this, always remember, this is considered Z equal to 0. Why this is considered Z equal to 0? Sigma standard deviation is 1, mean is 1. Okay, x is again 1. 1 minus 1 0. Because mean, median, mode coincide. So in the middle is 0. Okay, so z equals 0, z equals 0.5, 0 minus 5 plus 1. Always in the table with reference to 0 only table value will be given. So I cannot compute, I cannot find value from this point to this point. If I want to find out, I have to go from 0 to this, 0 to that. I have to add. So for this distance, I have to find 0 to 0.5 and 0 to 1 in the table. In the standard table, from area, I cannot, what I am trying to say is, I cannot find the value, the area between minus 0.5 to point plus 1. With reference to 0 only, table value will be given. So I have to find first 0 to 0.5 this way and 0 to plus 1 this way. Area is never going to be negative. Will area be negative? No. This point only is negative. The position is only negative, but the area is now never negative. Can area be negative? No. Only I am getting this area. This only positive. Only with reference to 0, the table will be given. So I have to find 0 to 0.5, 0 to 1. I have to add that. That is the area between 0.5 to 1. Okay. So that is what. Let's go to the next one. I think I am audible without the because I used to teach for 300 students also. So, the area curve. So, area curve is given like this. Now we will go area. So, with reference to 0 only you can find the values here. Okay. So, 0 to 0.5. Somebody is able to see here. If you want to see 0 to 0.5, 1915. The area is given like this. இதை ப்ரொஜெக்ட் பண்ண முடியாதுல்ல?
இது ப்ரொஜெக்ட் பண்ணலாம். இது ப்ரொஜெக்ட் பண்ணலாம்.
முடியாது. அதுதான் பார்த்தேன்.
For
0.5 எப்படி பாருங்க. Just look at 0.5. That is what I have given. 0.1915. 0.1, just 1 for 1. No, 1. You are not 0.1, just full 1. Complete 1. Understood? Yes, you have to refer to the table. The table values are given. Okay? So here you will for 0.5, you will refer to 0 column. Suppose 0.51 means 5, 1 column. Like logarithm book you look at. You know how to look at logarithm. Similar to that. Okay? So you take the values and you add that. Because this way 0.5 and the other way 1. So I am adding it. So this area is 0.3413. Okay? This area is 0.5328. So I want this area. So this should be added. Understood? When you add, you are getting, so 0.34, this is 3413. When you are adding it, this is 1915, 3413. When you are adding that area, you are getting here 0.5328. Your n was, what was your n in the problem? Problem n was 1000. Go to the previous problem. Go to the previous slide, sir. See, your n is 1000. Is it not? So for n, you have to compute. So go to the next one. I'm sorry. 528 into 1000. So 532.8 means 530 students will fall between 100 and 130. Understood? So first application.
Out of 1000.
Out of 1000. Out of 1000, 530 students will fall between 100 and 130. So given the limits, how many percentage of cases will fall within that can be decided with the probability term. Okay? Clear up to this? Next application. Given the percentage, between which limits these percentages will fall? Okay? Between which two limits the given percentage of cases will fall. That is the second application. Go to that. Next one. In an achievement test, the mean is 100, ST is 10. The middle 70% of the cases fall between what scores? So, I have given mean and ST. Middle 70% of cases will fall between which two scores? I have given the percentage now. The reverse of the previous problem. Given the percent, I am going to find out the limits. Do you get the point? Earlier problem, limits are given. We are. That is my question. If you are 90% also, you can do it. Okay, you are going to find out how many given that particular percentage of cases, how many students will fall between these two, any two limits. What are the limits under which the 70% of cases will fall? That is the question. Okay, you go to the next one. See, when we talk about middle 70%, it means I said the law of probability curve is symmetrical about the middle ordinate. Is it not? Okay, so middle one, middle 70%. So here 35%, here 35%. Correct? This is middle 70%. 35. Okay. So convert that. Z value corresponding to 0.35. Here now you have to look at the table from area to the limit. Earlier from the limit to area you are working out. Okay. Now you have to look at the area. From that you have to find out the limits. Because area is given. What is given is area. Remember, earlier limit was given, so we were looking at the area. Now the area is given. 35% is 0.35. Why? Because total area is 1. Okay, so this way 0.35, this way 0.35. I said you cannot find total 70 always with reference to Z equals 0 only you can do the calculation. So 0.35, 0.35. This side you should put minus, this side you should put plus.
Total area -1 to +1.
-1 to +1. Minus sigma to plus sigma, not even -1. It is minus sigma infinity to plus infinity, but the total area is 1. The area covered is 1. Limit is minus sigma to minus infinity to plus infinity. Okay, so now for the looking at this from here 0.35 I have to go to the limits. For looking at 35, I am getting the value as 1.04. Where the 0.35 falls when look at 1.04. Do you get my point? From this I am going to look at the two limits, x and y values. Okay, so it is 1.04. So when it comes to this way, it is minus 1.04 here plus 1.04. That's all I got. So z equal to x minus mu by x minus m by sigma. So that is plus z. This is what is getting is z value is only given here. Okay.
You are giving the sigma, it indicates a standard deviation.
Yeah. Okay. X minus m by sigma. So plus or minus 1.04 sigma equal to x minus m by 1 plus, of course, 1 plus by sigma. Okay? Now 1.04, what is sigma value here? The previous problem, that is 20. Okay? 20. And the mean is 100. So 1.04 into 20 equal to x minus 100. You get, are you following this computation? So x minus m by sigma equal to z. Z we found from the table 1.04 plus 1.04 minus 1.04. That's equal to plus or minus 1.04. That's equal to x minus 100. So 1.04 into 20 is nothing but plus or minus 20.8. So, taking 100 the other side, 100 plus 20.8, 100 minus 20.8. 100 minus 20.8 will be here, 100 plus 20.8 will be here. If you don't follow, you ask me, I will work it on the board also, no issues. Okay? Because I thought 1.5 hours will not be suffice for me to complete.
Yeah,
That's why I put everything in the PPT. So this is 120.8 and 79.2. So this point is 79.2. This is 120.8. Between 79.2 and 120.8, the middle 70% of cases will fall. You get the point? In the test, between 79.2, the person who are getting above 79 and those who are getting below 120, 129, that is middle 70%. Getting? Okay. This is how, given the limits, given the percentage, I can find the limits. Some middle 70% within which limit I can find it. Earlier, limits are given, we converted that to percentage. How many percentage will fall between these two limits? Now, percentages of cases are given within which two limits these percent will fall. That is the second application of law NPC. Okay? Shall I proceed? Next one. Where is the Q1 point will fall? Q1 is 20, P25. First quartile. First quartile is Q1. So, below which 25% of cases will lie. Below the point B. See? Totally, this is 50%, this is 50%. Is it not?
Yeah.
So, this is 25, this is 25. 25, 25. So, below this point, below B, how many percentages will fall? That's the question. Can you follow this figure? Okay. So, totally 150%, 50%. This is Q1. Below Q1, 25%. Below, above Q3, 25%. So, I want to find out what is this point. What is the value of this point? Below which value, the 25% will fall. That is the question. So, now looking at the table, point is a table where the 0.25 will fall. That area you have to see again, reverse, going in the reverse form. From 0.25, I got to look at the X and Y. You have to look at 0.25 here, look at the values here. Okay, that value we found to be 0.67. At 0.67, the 25 value will appear here. Okay, if you want, just look at it. 0.25 is 0.67, so that you know how you are identifying. Look at this, where 0.25 is. So, this is why I put minus, I attach minus symbol, because left hand side. The question is on that. This is left, this is middle ordinate, this is 0, negative, positive. So, that is why I attach minus 0.67. Minus 0.67 equal to x minus m by sigma. Your mean is 100, sigma is 20. So, minus 6. I just cross multiplying into 20 equal to x minus 100. Minus 13.5 x by 100, taking 100 other side, it is 86.6. So, the first quartile falls at the point 86.6. If you don't follow, ask me, I will work it out. No.
By 7.
So again this 0.6. Yeah. 7. So 0.6, 0.6. Understood? Understood this? Understood? Can you proceed?
Yes, ma'am.
I mean very fast.
No fast, but our student of you is.
I can
Okay, going further. Next.
Yes.
Next. Similarly for Q3. Where will Q3 fall? Okay. So, similarly Q3 is the third quadrant below which 75% of the cases fall. I cannot find 75 because again with reference to x-axis,
Ma'am, there B indicates what, ma'am? Corresponding to B.
Q1.
Instead of the Q1, you are using the B now.
B, yeah. B dash is Q3. So now Makam. This should be your Q3. Is it not? Below which 75% will fall. Okay. So this covered 50%. Because it goes above, another 25% is there. Okay. Always with reference to table, you cannot find the area above your point. You can only find the area below your point. Remember that. Okay. Even my question says, how many students will get above Q3? I cannot find above Q3. I have to find below and subtract. Take the complements. Okay. Area will give you only about values that lie between that, below that, not above that. So 50 plus 25. So I am taking it as equal to plus 0.67. The same 0.25 when you look at the value, it is 0.67. Why plus? It is on the positive side. Earlier Q1 is on the negative side of median. So we plotted it as minus 0.0067 sigma. Now this Q3 is on the positive side of median. So that's why I use the symbol plus 0.67 sigma. The same formula. Always the formula is the same. X minus m by sigma. So 0.67 sigma into 20 x minus 1 taking on that 113.4. So at the point of what this is only 113.4. At the value of 113.4, the Q3 of the given distribution will fall. Okay? Got it? You must be very careful in assigning the signs, either negative or positive. But going to be below z equals 0, negative. Above z equals 0, positive. Below the median, negative. Above the median, positive. Because median is the central ordinate in the noun problem. Okay?
Finally, what it indicates, 113.4 means.
Where will the Q3 value lie? Suppose I am going to research, I am going to take students above Q3 as a high group. So those who are getting above 113 will be taken as a high group student.
These are the standard values.
No, for this particular problem.
Yeah.
For this problem, I am getting 113.
Now finally, 113.4, what it indicates finally that.
It is that value of Q3 in this distribution. In the given distribution, the distribution of, go to the problem, sir. Go to the problem. Earlier. Previous. For this problem, Q3 will fall in 113. For the problem in which 100 is the mean, ST is 100, Q3 falls at 113.
The point you are writing, the 3 points are there. The middle one, left one, right one. The point is Q1, the point is Q2, the point is Q3. You are saying.
This
point.
is only this point.
Yeah, okay. Those points are Q1, Q2, Q3. What about the area? We are split into 25 each now. The area is Q1 or the point is Q1?
Point is only Q1.
Then what is area?
The area is number of cases who are going to fall within that.
So that last area is called Q1 area. And we
This is
take it
Q1
as
area. The whole thing is Q2 area. The whole thing is Q3 area.
Q3
Yeah.
area.
This is above
This
Q3
last
area.
is Q3 area.
This is above Q3 area. This is above Q3 area.
Okay.
From here to this Q3, below Q3 area. This is between median and Q3 area. Between median and Q3 area, this one.
Yes.
Okay, this is below Q3 area, this is below Q1 area. What I am referring is point only I am referring. Value. You are conducting a test for 140 score. You want to divide them into 4 groups based on Q1 and Q3 value. Suppose your test is for 140, so the maximum score is for 140. I want to divide them into 4 groups.
Yes.
Based on, I said scientifically you can divide them using Q1 and Q3. Suppose your Q1 values happen to be 21.
Okay.
This arbitrary I'm giving, it may come around to something else. Q2 value happen to be somewhere 84, suppose. And Q3 value happen to be 91. Okay, how will you divide? Students getting less than 21 are considered as a group 1. Okay.
Okay.
Those who are getting between 21 and 84 considered as group 2. Group 2. Between 84 and 91, group 3. Above 91, group 4.
Okay. Here the Q2 is very big. Q1 is very small. You take that last one.
Because Q1 is 25%,
Yes.
Q2 is 50%.
50%.
That's the reason. Very good.
Okay. It is a point which divides into 2 equal halves. Maybe my diagram will look like, go to the
No, not like
standard thing, you will get that. But the area is always covered in that way. This is 25%, 50%, 25, 25. Okay? This applications, all these things applications when they want to do a scientific research, divide the whole population into certain number of groups. There are situations you will apply like that. Okay, you are introducing a treatment experimental research. I want to see this treatment is effective for which group. Low group, it will go for high group.
Ma'am, here is up to Q2, this is a negative value is there. -1, minus like that.
Value is negative, but area is positive.
Yeah, that's why.
Area is always
That is the
positive.
confusion. That's why if you want to say the area, you are treating it as 75% up to Q3.
Yes.
But whereas in a point of view, it's a negative and this is a positive.
This value is only negative, sir.
Ah.
But the area will
Yes.
never be negative.
Yes.
Anywhere, the area will never be negative.
Yes, good.
Okay? Only the value is negative. Understood? For calculation purposes. Because negative side of the x-axis it is. Yes? Any doubt?
I hope girls are having doubt. By
Yes.
seeing their faces, I can say. Am I right?
I'm asking the questions
See,
on
it's
behalf of
Sanjay
students.
Bodhikar
You have to ask
Kuchantu.
such questions.
Varam varam. Varam varam
On
sasya.
behalf of you, I'm asking the questions. No, that's not correct. You have to ask the questions. అది చాలా బ్యాడ్ క్వశ్చన్ అర్థం కాలేదు.
Ah.
సైడ్ మొత్తం మైనస్ ప్లస్ అప్పుడు ఏం చేస్తున్నారు ఫస్ట్ పాయింట్ ఏం చేశారు మళ్ళీ టోటల్ హాఫ్ చెప్పండి
అది స్టూడెంట్స్
See, his question is, this area is Q1. This area is Q2. This area is Q3. Whereas, this area is above Q3. Don't say it is Q4. No, nowhere Q4 is available.
Yeah.
Okay?
Yeah.
Nowhere Q4 is available. This is above Q3. That is his question. Okay? Because somebody somewhere else must be having the question. That's why I just put across the whole population.
Thank you.
By the way, what is population? What is the sample?
Okay.
What is population? What is the sample?
People, students, you know, tell.
Population.
What is the difference between the population and sample?
Population is the whole
Yes, the
universe.
representative
Population is the whole universe. A sample is the representation of the population.
Yes, yes. Population is the whole universe. As you rightly find out, sample is the careful selection representing the whole population. It should reflect all the traits or the characteristics of the population. Your samples should reflect all the traits and characteristics of the population. Okay? Yes. Next one is, about what score the top 10% of courses will like? So third question. See, above what score the top 10%. For example, IIT classes, IIT students are, Suppose students they are going to recruit, admit students for IIT. So they are considered top 10%. I'm just arbitrary statement I'm giving. Okay. So the top 10% will be admitted for some course in IIT. Okay. How will I identify which is the top 10%? That's the question. At which point the top 10%, above which point the top 10% can be considered? That is the question. You go to the next one. Go next. Next. So here, I have given the diagram. 50%, remaining 50%. So this is the point. The top 10%, the 40%. So here 50%.
40%.
This is 40%. This is 10%. What is this? This is my question. What is the point? Where top 10% will like? This is the question. Understood? Okay. So now from the normal curve, Z value corresponding to C. So I want to find out this 10. For top 10 I cannot find out. I said for top values we will not get the value in the table. So I have to see only 0.40 in the table. Only below you will get areas in the table. Area under normal. The word is the area under normal curve. So below only I can find the values. So top 10% or top 10 I cannot find. What is that? 40. Below 40. It indicates about it. Okay, I will look at the value for 0.40 corresponding rows and column. I am getting it as 1.28. The exact value corresponding to is 1.2 in here, 8 in 1.28. That's the value you get 0.40. We get the point? So 1.28, why it's positive? Why don't you attach negative sign there? Why don't I put 1.28 as negative? Why I didn't attach negative sign here? That is on the positive side. In the see the figure it is on the positive side. If it would have been bottom 10%, I would have attached minus 1.28. Clear?
Yes.
If I am interested to find out bottom 10%, I would have attached minus 1.28 here. Since in the positive side of the curve, it is plus 1.28. So 1.28 equal x minus 100 by 20, multiplying everything, you are getting 125.6. So those who are getting above 125.6 are considered as the top 10% of the given distribution. Above 126. Okay, can we take
Same question, if you ask below 10%, it comes under the left side.
Let's say. I have given the next problem that way.
The value will be same, but it will
No,
minus.
value will not be. That 1.28 value will be the same.
Yeah,
Calculation will vary.
Okay.
So not.
Ma'am, how can write 0.40 table value and calculate value? That is 0.40.
0.40 you see.
That is table value, ma'am.
Table value. Table value. Area value. Area value given in the table. From that I have to find out.
Wi-Fi password is Wi-Fi connection karo.
Yes, ma'am.
Okay.
Okay, ma'am. Okay, it's left.
So next one. Next problem.
Normal property curve table is.
Table Darshan. Madam, our students would like to see table in internet.
Okay.
They are unable to understand how the value
Okay,
is.
I have. You do have network here?
Yeah.
Yes.
Okay.
The table in next
Now area under normal property curve.
area under normal property curve table area under curves.
C-U-R-V-E. First one.
Table
Lodge. Yeah.
other table is this
No, not this.
Mr.
Go, first one. Go to the first one.
First
Go
page,
back, go back.
Either page Nishkasi. Why use page Nishkasi?
Go back.
Remove the Byju's page. Remove that also. Yes.
First one.
And
Got it.
please.
0.40. Where is 0.40 appears?
Good.
So you see where is 0.40? This one. Okay. This is 0.3. Okay, this one. So you look at the corresponding here, 1.2. Here? 1.2, 0.08. 1.28.
Where is that one?
This intersection of 1.2 and 0.08 only 3997.10. This is the area. Understood?
Yes.
This is what we are getting.
Which one, ma'am?
Huh?
Which one?
3997. 0.3997.
This is 0.40. Corresponding to this 1.2, 0.08. So it is 1.28. Understood?
Not there.
No, why not there? See, I said in the curve this is 0.40, 0.40. Where will this point lie? Yeah, this value given is only area, that is the points, limits. Where will 0.40 appears in this table? 0.40 appears only here, not this before that, 3997.
0.40 kutra asti tatra. Left side pashantu.
Point
From area you are going back to the limit. The problem is from area you are, because I am only referring to area, I am not referring to the value. Okay? Understood?
1.2.
1.2 and here 1.28. As you are referring to last table only. You convert, you say in Telugu, I don't know Telugu. I know only English.
Ma'am, their question is, first of all, what is meant by 1.2 and what is meant 0.08? First they want
Where is
to know that.
1.2? Where is 0.08?
Where will the
They are asking.
where will the area of 0.40 lie? Intersection of which value the 0.40 lies?
Others number is I will put it, no?
How can you put? You cannot put. Because see, this is only 0.40. This area is only 0.40. I want to say which point the 40 will lie. What is the Z score corresponding to? This is Z score table. This is Z score table. See, Z is given there at the left hand corner. At which Z score the 0.40 will lie. So this point will, this area lies. This is value where 0.40 lies.
Okay,
This is the
ma'am.
intersection
How
of.
that point is a 0.40? That is the question.
Our students are substandard. Why? Because what they are asking, they are asking about the 1.2. Where is that? How to identify that 1.2? That is their question.
Driver,
We
wait.
are writing 0.08 na? And 1.2. How to calculate where the 1.2 and 0.08? How to? The basics are asking.
No, this is a standard table. We are not calculating anything.
Yes, but 0.40 is where, how can you say that is the 0.40?
This is not 40. Is it not 40? 3997.
No, that is nearby 40.
Because it goes beyond. If I go to that,
If you cross that limits the A4.
See, first question is 3997 అది 40 కి దగ్గర ఉంది.
yeah, very
ఆ
close.
values
Very near to
పైన
40.
value కలిపితే
So that point we should take.
అట్లా కాదా
ఆ 0.04 వాల్యూ అనేటువంటి అక్కడ ఎక్కడ ఉందంటే ఏరియా చెప్తున్నారు.
ఏరియా
ఆ
ఉంది
ఏరియా దాటి నెక్స్ట్ ఏరియాకి వెళ్తే అది దాటిపోతుంది. 4 దాటి
Yes, it
వెళ్ళిపోతుంది.
goes beyond that.
అందుకని దీంట్లోనే ఉంటున్నాను.
ఆ
Just like
values
CF value,
ఉన్నటువంటి line
do you know cumulative frequency exact where the n/2 values comes under the CF? If you take directly, it minus. That's why you are taking the CF value above. Nimna tarah hoti. But if you are not taking that, it's not, if you go another, it crosses 4 wells. That is the reason.
You cannot extend area. You cannot extend your boundary. You can construct a compound wall only within your boundary.
That is the area. 40% means 0.40 is the 40% of that area. Understood? Are they understood or not?
Yes, sir.
Right.
See, you can construct your compound wall only within your boundary, not the neighbor's boundary.
Yes,
Don't go to the
exactly.
next
If you are going to see, you are encroaching others'
Okay,
place.
don't go to that. I can use my area.
Yeah.
Okay.
Right.
Clear?
Are you clear or not?
Yes, sir. Yes, sir.
Okay? Yes. You minimize this. You minimize this table, go to the PPT.
PPT, go.
P5. Slide 2 from current slide. Okay, so we got that as next one. From the next problem. Below which point the bottom 20% will lie? Now we saw top 20%. The bottom 20%. So bottom 20% is 20% here, 30% here. Okay, so you have to look at for which area you have to look at the table? For which area you will look at the table?
Bottom 20%.
40%.
Bottom 20%. 30% and 20%. Left side, na?
Yes, sir.
From which point 20%, the bottom 20% will lie. Okay, so below this point 20% will lie. Rest of the 30% will lie here. Always my focus is z equal to 0.
Yes.
Okay, so I cannot look at point to 0.
Yes.
It refers to the result only, always try to refer to the table. So I got to look at 20 for 30%. You have to refer to the table for 0.30.
Oh.
Remember that. Always with reference to this I can do anything.
Yeah.
Not this way or way. No yet I can refer to NPC.
I think
Only with
because
refer-
there is never touching these rulers, that is the reason.
Yeah. Because it's asymptotic in character, I cannot refer to that.
Yes.
Left or right.
That is the reason.
Z equals 0. Only with reference to that I can say. Point 2 is nothing but other side of 3. Is it not? I am
Yes,
taking 2
yes.
this way, it means other side of 3 it is. So I can look at go to the area. Now you go to the area table. So I have to
We
look
have
for
to see the 30% of that area, na?
0.30 I have to go to the table. Where does 0.30 lie? My good friend, you should
yes.
answer. Please get it.
Go on.
Get up.
ಇದನ್ನು ಸರಿಯಾಗಿ ನಾನು
No
ಚೆಪ್ತವಂತೆ.
problem, come here.
ಗತ್ವಾ ದರ್ಶಯತಿ ಕುತ್ರ ಅಸ್ತಿ
0.03.
0.30. No problem, come here. Everybody is saying the same
30%
word.
means if you convert 0.30.
0.30. Where will 0.30 lie? 30.
0.
Go. Under.
ज्यादा हो गया ना?
ज्यादा हो गया ना हाँ उसे पास
0.30.
0.30
29.
हाँ 2995 अस्ति बोलो
Okay, exactly. But
एक्सैक्ट अस्ति खलु 0.30 2 दिया आगतं खलु
Goes beyond.
थोड़ा ज्यादा हो गया
you are identified.
थोड़ा ज्यादा हो गया ना इसमें 0.30 हाँ थोड़ा ज्यादा है ना तो ये लेना पड़ेगा उससे
Now,
आगे
what is the value? You tell me the value now. You tell me the value.
Right.
0.30. What is the value? 0.8. Yes. 0.8. 0.84. 0. Look at 0.8. 0.04. 0.84. First decimal place, second decimal here. First decimal left hand right, second decimal left.
0.04
Okay?
0.12.
So I have to 0.8.
Very close to that. You should not go beyond.
Yes. That's correct.
0.30. Please, sir, you should not go beyond 0.30. Still that. I can start only up to this. Not beyond this. If I go beyond, I fall off. My limit is only this. Okay? That's all. That's very close to it.
Finally, the 30% of that 0.84. What is that?
I'll go to that. Yes. You got the point, now you go to the problem. Thank you. See, 0.84. I am substituting here. This is 0.84. This point is 0.8. Is that value? Is that value corresponding to that point is 0.84. We are substituting that here in the table to find the original data for this.
Madam, how can you fix that value in that place only?
Which place?
0.84 comes under.
You got, because 0.30 area, that area, this is the line. So this is only 0.84. We got that from the table, no 0.84. So I am fixing it. This is the point. Okay. Understood? Now we are putting attaching minus sign. Why?
What their question is, what 0.84 indicates?
It indicates a P30.
It indicates
The point below
Yes.
which 20% will
0.84
fall.
what it
The
indicates.
point below which is that score corresponding to the point below which 20% fall. Is that score corresponding to the point where 20% fall is 0.84.
Yes.
But I want to find out what the original score below which P20 fall.
Avagatam?
My question is not Z score. My question is the original data. Is it not? From the Z score I am going back to original data. 0.84 the Z score corresponding to where P20 fall.
ఆ పాయింట్స్ కనిపెట్టేస్తే అక్కడి నుంచి మనం ఆ డేటా ఎన్ని పర్సెంట్ చూడొచ్చు.
The real score data ఎంత ఉంటుందో తెలియదు మనకి.
ఆ పాయింట్
20% you are talking about the percentage. Your sample may be 370, your sample may be 500, your sample may we cannot say your sample size. But we can say in the percentage wise. That's why madam has taken in the percentage wise.
Okay, so point is 0.84 substituting 83.2. 83.2 is the value at which P20 fall. Those who are getting 83 less than 83.2 are the bottom 20%. The question is, who are the bottom 20% population? Those who are getting below 83 are bottom 20%. Bottom 20%. Original score. This 0.84 is refers to Z score. So this value for the original score is 83.2.
Madam, if you don't mind, can you give one illustration? For example, sample is 370. How much percent? How much score will be comes under the less 20%? Give me one illustration for this.
You need the mean, you need the SD.
Yeah, that is the reason.
You follow, for working on all these things, you need N, you need
and
mean,
M.
you need S. If all the three are given, you can do any case.
Because suppose my sample is 400.
Okay.
400 sampling 1%.
How many
Mean
effect?
mean
Mean
SD nothing but
You are giving me only N. What about this? You give me these two also, then I will tell you.
400 का mean ले लो और SD ले लो.
Okay, I will tell you. Where the P20, how many will be?
Can we assume and can we check it?
We do
Yes.
it, no problem.
For example, for this can be assumed and you calculate the value. Then you will get us.
See, suppose your N is starting says N equal to 400.
Yes.
Your mean is say 72.
Yes.
Mean say 80. Sigma say 10. Suppose this is my.
Yeah, that is
Okay,
right.
this is right. You want where the P20 will fall. Is it not? Okay?
Yes.
So how will you do? Convert. See here, the same thing. The same thing. P20 means 50%. This is P20. Below 20%, above 30%. Always with reference to this. This is very important. This is with reference 0 only. I can do anything with the result table. So I can look at 0.30 only here again. Because 20% above 30%. What is 0.30 in the table? 0.84. Is it not?
Yeah.
So is that equal to x minus m by sigma? 0.84. Is it positive or negative?
Yes.
Negative.
Positive or negative?
Negative.
Why?
We have got the less.
Because left hand side of the median.
Yeah.
equal to x. X minus median 80 by 10. Okay. Minus 8.4 into 10 equal to x minus 80. This is 8.4 minus 8.4 equal to x minus 80. 80 by
Some calculations.
X equal to 80 now.
not x bar. X bar is only 80. I mean
X bar.
Mean.
X
bar is nothing but
Mean.
mean.
Right.
Instead, please.
So 80 minus 8.4 is x. So it is, what is that? 71.6 is x. So for your data, P20 will fall at the original data of 71.6. Those students who are getting below 71.6 are considered as the bottom 20%.
Yes.
Understood?
Final conclusion, man. Below
Those who are getting
71.6.
below 71.6 as a score
Yeah.
are considered as the bottom 20%.
Yes. Understood?
आपको करके देखना पड़ेगा.
Okay, you take photo also. Generally you can understand.
Understood? Now understood?
Yes.
Don't follow the photo. It should be here. Okay. The verbal photo is very much necessary. Okay?
Done.
This is, you go to the next one. I think I have covered all the applications of novel property curve as of now.
Yes.
Okay, with this novel property curve comes to an end.
Yes.
Okay, shall we proceed? Madam, next class.
Okay. Okay. Conclude, man.
Huh?
Next is movie.
Okay. So with this, you will use normal property curve. Of course, normal property curve has got this enormous application with reference to parametric testing. Forms the basis for application for parametric testing. That is the high level strategy we are doing your research. At the PhD level, not even at ML level. You can think of doing testing the normality even at the ML level. Okay? I will continue with next.
Thank you.
जननीं शारदां देवीं रामकृष्णं जगद्गुरुं पादपद्मतः श्रित्वा प्रणमामि मुहुर्मुहुः नमः शिवाय गुरुभ्यो नमः। अद्य शैक्षिकानुसन्धान विधि विषये द्विसप्ताहात्मिका राष्ट्रीय कार्यशालायाः नवम दिवसस्य अस्य प्रथम सत्रस्य अन्तिम चरणे स्म। अस्मिन् सत्रे प्रोफेसर एन कलाई आरसी महोदयाः नॉर्मल प्रोबेबिलिटी कर्व इति विषयम् उल्लिखित्य अस्मान् अति सरलेन विषयस्थ सूक्ष्मातिसूक्ष्म ज्ञानं शिक्षितं। महोदयानां कार्यशाला पक्षतः केंद्र पक्षतः शिक्षा विभाग पक्षतः विश्वविद्यालय पक्षतः मत पक्षतः च हार्दं धन्यवादान् ज्ञापयामि। एवमेव कार्यशालायाः अस्य भूरि परिश्रमं कृतवद्भ्यः निर्देशकेभ्यः संयोजकेभ्यः सहसंयोजकेभ्यः सहृदयेन धन्यवादान् वितौमि। एवं क्रमेण बहिः विश्वविद्यालयात् आगतेभ्यः अध्यापकानां च भ्यो धन्यवादान् ज्ञापयामि। एवं च भागगृहीतॄणां च हार्दं धन्यवादान् विज्ञाप्य विरमामि। धन्यवादाः।